Alright, today I want to try to implement something that's called the convex hull. Convex hull is basically a structure that wraps a set of points. So here is an example in 2 dimensions. You have a set of points and you have a polygonal convex structure that it kind of wraps all the points, and you can think of it as taking kind of an elastic band coming from outside, from infinity, and just wrapping it as tight as possible around the points. So it will kind of like wrap the outermost set of points. And I want to use it as a way to get a triangulation of this bunny structure that we looked at last time, or any structure. And here's an image in 3 dimensions. We can see kind of the type of structure we'll get. I found this book, I'll put a link in the description, that has a pretty decent explanation of how it works. So let's try to take a look at that. The first thing we're going to do is start tmux, and then I think we will make a new file that we call hull. And this file will just have sort of like a simple test implementation. So let me fix up my run script. Maybe now we'll have like a file parameter, and we hull.c, and here we'll put file. And now we can run it, and it says it exited successfully. I'm going to disable Copilot because I think it'd be nice if we don't have to. We can think a little bit. So let's make let's call it a prototype, and close the window, and we'll have the main loop. Drawing and drawing, and we will do a couple of other things. We should set the target FPS to 60, and let's make some kind of uniform background like that, and let's draw something on the screen. We'll just draw the FPS to see that it's working. So that seems to be working. Now let's get some 3D set up. So I think we need a camera. So we need to define that. I'm going to copy what we had in the main file. So I think you can go here. Here's a nice camera. And I actually took all this camera fix code that we had. For some reason I couldn't get the implementation from Raylib to work, so I made this file that just has all of that fixed camera code. So we're just gonna include that, and now it should work. So let's try to draw like a sphere or something. And how is it that works? I'll draw a sphere, copy that one over. We need a position. Maybe we'll put it up here. So center is, I think there is a function called 0, so let's use that. The radius, perhaps it's just this, and the color can be red. And finally, we need to call update camera, so we can control the camera. And that's because it needs a mode as well, so I think we can use camera free. And let's also go into the main file and have this thing where we focus on the origin. So okay, so here we see it, and we can kind of look around. We should also disable the cursor. Great. So now I can fly around and I can look at this sphere. Okay, so how does this algorithm work? We need a set of points to calculate the convex hull for. So let's do that. Let us do that. And I think we're going to want to remove points from that array as we kind of like build the convex hull. So I'm actually going to make a dynamic array. We'll call it like this. And it will have some points. It will have an count and it will have a capacity. And then we can use this macro, which takes a dynamic array and an item, and then first it checks whether the count is greater than the capacity, and if it is that, we need to increase the capacity. And then we actually need to reallocate the items. And if I'm not mistaken, it's the items first, and then it's the capacity. So we reallocate those. And finally, we are going to say, put in that new item right there at the end. So let's go ahead and also put this thing here, maybe like that. All right, so I think that should work. So let's make one of these arrays. The count is initially 0. The capacity can be 128, and then we should, well, the capacity can be 0 as well. Maybe that's a bit easier. But then we need a check here that if the capacity is 0, then maybe we just set the capacity to 1, and then we double it, something like that. Let's try that, because now I can just easily initialize it. Actually, I don't need to do anything. I can just initialize it like this. And then let's define a couple of points. It could be point 1. And let's have a parameter. Not sure why it stopped. Okay, maybe we'll see that later. Okay, so let's have a parameter called spacing, which can be this number, and then we'll have like spacing 0, 0, and let's make 4 of these. This is kind of like the minimum that we're gonna need to make an interesting convex hull algorithm. Wait, so actually I want to do this, and then this, and then finally this. Right, and then let's append all of those. Let's see if that works. So that didn't work. And why didn't it work? Meaning a semicolon probably is part of it. Ah, We also need to remember to add those because it's a macro. And it's not a, there's nothing called a point, it's a vector 3. And now it runs and it crashed. Is it gonna crash again? No. Now it did crash. That's interesting. So it must be this code that we just added. So that's fine. And we also have an implicit declaration, so let's fix that by I think it's in string. It's really weird that it just crashes. Invalid chunk size. So if count is greater than capacity, maybe there's a problem with this. No, it's pointer and then size. And items is a pointer. Didn't think there would be this much trouble just getting a dynamic array working. So let's say reallocating. So new capacity. And it's going to be dA capacity. And let's just close the window here. And yeah, I guess that's fine. Let's do it like that. And again, I forgot. There must be a better language than C somewhere. Reallocating to capacity 2, reallocating to capacity 4, that's all fine. Do we really need to? Cannot be. It cannot be. Right, let's get rid of all of this. Okay, so realloc is not in there, maybe it's in here. Okay. That seems to be working. So now let's re-enable this stuff. And there's a segfault. Which is weird because I'm not using the points anywhere. Maybe we need an assert. This is very bizarre. And if I remove the assert, alright, not now it crashed again. Okay, maybe we need size of vector. That's probably the issue. Yeah, I think that's it. Because it's here it's a void pointer, so it needs like the size in bytes. Yeah. All right. Now we have some points. Let's draw them. All right, here they are. We should put the size into a variable, so let's call it radius. And we'll just put the radius up here, and maybe it's like quite small. And here we have them. Very nice. You can see they're kind of, I don't know if it's how easy it is to see, but they're kind of forming a pyramid. So, when we're building this convex hull, we are constructing a set of triangles that make up the convex hull. So I also want I wrote the same thing again. I want like a dynamic array of triangles. And it's essentially going to be the same, except it will have a triangle here. And what is a triangle? Triangle is just three corners. That's all it's going to be, and we'll call it like A, B, and C. Why not? Right, and then let's make a triangle array. Triangle. We'll call it tries, and it's also just 0 to begin with. And then let's draw the triangles. And I think if we go to Raylib, there is a draw triangle 3D. So we can go ahead and draw that. And there's also draw line 3D, which I would also like, I think. So now we just say, let's get the triangle out. This, then we get the 3 triangles, so try A, try B, try C, and the color, maybe the color is blue. And here for the line, starting position, ending position, I want to do something like, let's draw a line from A to B, and that color can be, let's make it green, so it's easy to see. And then I want one from B to C and one from C to A. Now, of course, right now we don't have any triangles, so it doesn't really make sense. But let's do the following. Let's maybe say add triangle. So it's gonna add a triangle to the triangles array. It's gonna take the points from the points array, and we'll start at index 0, and then it will take the first 3 points. So it's going to be modifying these arrays. So here we have a pointer to the triangles, here we have a pointer to the points, and here we have a start index. So let's first construct like the new triangle, and I guess we can do something like this. We don't need that. We don't need that because it's actually just points, items, start index. And this is just the first one, and that's the second one, and the third one. So that should give us that. Maybe we should just, for good measure, let's assert that the count that start index plus 3 is less than count. And we construct a triangle. Let's add it to here. And then let's go ahead and remove them. Remove these points from the points array. I think that's okay. It will change a little bit how we plot things, but let's just do it. So DA, let's make a new macro, I guess, where we remove from the points and we remove this index. So it's going to be remove at. We'll define it up here. Define DA remove at. It will take the dynamic array and it will take the index. And what will it do? We are not going to do any checking here, I think. So we are just going to say let's, and maybe we should like obfuscate this. Remove add 0. That's a bit annoying. Let's call it I. So I is actually I should start at the index and it should go to the count, and then we're gonna take whatever is at that index and we're going to override it with the next one. And then I think we need to do this. This. Yeah, so this is the one we want to remove in the beginning. Sorry, this should be I, and this should also be I. So in the beginning, this is what we want to remove, and we just override it with the next one. And then the next one is now in 2 places, so in the next iteration of the loop, we can go ahead and override it, and we keep doing that. So then we should say DA count minus minus, and I think we're done. This is not a super efficient dynamic array, because every time you remove something, you have to loop over everything basically, but that is probably something we can think about another time. Right, so that should hopefully work. We'll go here and we add a triangle, and let's see if that works. So it didn't work. There's a problem here because I don't know. I think I'm programming in Odin or something. Okay, so now you can see something kind of went wrong because we're supposed to remove the 3 points that are at the corners of the triangle, but we didn't really do that. So there's also another thing I would like to do, which is disable backface color. So apparently that's not defined here, so we need to get RLGL. So now if I got this bug again, what the hell? And I said size of vector 3, which is also clearly wrong. It should be size of the first item. So I guess we need to do something like this. Okay, here we go. So we have this triangle and I'm moving very fast, I feel like. Let's make this screen just a little bit bigger. Let's make it 1000 by 1000. There we go. There we go. mouse movement is very fast for me, so I'm going to change it a little bit. Mouse move sensitivity, maybe half it. And here we go. So it's a little bit better. Okay, so something went wrong and we removed the wrong point. Right, so it's because here we are when we remove the 0th point, everything is shifted down. So we actually have to keep removing the one at point 0. And actually it should be the one at start index to be completely correct. Alright, that looks like it could be correct. Yeah, so this is the starting point for the convex hull algorithm. You need to have one triangle that's in the convex hull, and then you can get started. So let's make a function. This one we call add triangle. So let's make a function that we call expand convex hull. And we need the triangle array this is kind of like the hull. So we call it hull. We need some points that are not in the convex hull. Then we need an index. So let's call it try index. And we also need an edge index. So edges are the, yeah, I'm trying to explain something that's obvious probably, like it's the edge of a triangle. All right. So let's get the triangle out from the hull, items, the triangle index. And then we want to know which points we're considering. So let's call them P. Maybe just P1 and P2. So if the edge index is 0, then we're going to go ahead and say it's P1 is A and P2 is B. And if the edge index is 1, then P1 will be B and P2 will be C. And otherwise, P1 will be C, P2 will be A. So that will give us the two corners of the edge that we are interested in. And now the algorithm works in the following way. Let's say we are looking at these two corners the edge closest to us. We're going to go through all of the points that are not in the convex hull yet, and then we will try to make a test triangle there, and we will see what is the angle between the current triangle we're at and the test triangle, and we will choose the triangle that makes the smallest angle with the current triangle, and that will be part of the convex hull, because that will make sure that all the other points, they are kind of inside that triangle because they make a larger angle. So I think it's quite kind of intuitive, but I will also put a link to the book where it's explained maybe a little bit more. And this is also not the most optimal way to construct a convex hull, but it's the easiest to understand. So we need some way to measure the angle of two triangles with respect to each other, and we're going to use a so-called surface normal, which is a vector that is pointing perpendicular to the triangle. So let's just calculate it. It's a cross product, and it's a cross product of so actually let me also get P3. I think I will need that. here it should be A, and here it should be B. And then we can just take, let me think. So we can take like from P3 to P1 and from P3 to P2. And that will give us some vectors. So let's try to visualize that. For each triangle, let's calculate a normal, and let's say try C. So here we have some kind of normal. Now we need to draw a line, and maybe let's construct the center point. And I think we can, let's do it kind of manually because it might be nicer. So try AX plus try BX plus try C. X is the first component, except we need the midpoint. And then we can go ahead and replace X with Y, and we can go ahead and replace X with C. And now we can draw a point starting from the center and going to the center plus the normal that we just calculated up here. That will be red. And I accidentally wrote plus. So here we go. And if we look at desperately, we try to look over here. There's a, okay, it's very impossible to see what the hell is going on. So does this line, maybe we draw a cylinder instead, so it's a bit bigger. And how is this aligned? I don't understand how it's aligned. So we're actually not going to do that. Draw capsule, draw plane, draw ray, draw grid. Yeah, we're just gonna stick with a line, but then maybe we will make it a bit bigger. So we'll scale it by a factor of 10. It's red, and is this what we want? Maybe it's better if it's like starting from A. Okay. Made no difference. And why didn't it make a difference? Need to see where the back is. Okay, so it's just because they are kind of ordered in the wrong way. Or maybe not. Let's go ahead and switch those two around. It doesn't matter so much, it's just that I want the arrow to point outwards, not inwards. All right, so we now you can see we have this arrow. That it's a well, not really an arrow, it's a line, but it's the normal vector. It's a line that points perpendicular to the surface of the triangle. And we can use that if we have two of those for two triangles, then the angle between those two vectors will be the angle between the triangles. So now we have here, here we have the normal for the first triangle, the triangle that we're trying to add another triangle to. And then let's go ahead and loop over all the points that so far have have not been added. So let's go and get the point. It's kind of like a candidate point. And then we need to make a new normal. Let's call it new normal. And it will go, we can do the similar kind of thing here. But now the starting point is this, let's call it new point. That was kind of wrong. New point, like that. This one. So that will give us a something. Let me think about this. I think we may need this. Could that be? Yeah, I think we need to do it this way. So if you switch these around, you just switch around the direction of the arrow, and you kind of have to make sure the vector points in the correct direction. So I think this is correct. I'm trying to visualize it in my mind, so I get that's a bit hard to follow probably. Don't have a drawing program though. Yeah, I think that is it. Yeah, let's go with that. So we need to figure out what is the angle between the new normal and the other old normal. So we can actually just do a dot product between the normal and the new normal. But then we just have to make sure that we scale them by, that we're not affected by how large the vectors are. So we need a length, I think it is, of the normal times length of the new normal. And this is not really the angle, this is the cosine of the angle, but that's actually good enough for what we need. So let's say the minimum cosine angle, it can be 2, and the minimum index can be -1. So if this is less than the minimum cosine angle, then the minimum cosine angle is equal to the cosine angle, and the minimum index is equal to I. Go ahead, we can assert that the minimum index is not equal to -1, just to be sure. And then we want to do two things. We want to add a new triangle to the triangles, and we want to remove the point from the point array. Okay, so we can already go ahead and say, well, let's not do that. Let's first extract the point. So yeah, let's make the triangle. Let's make a new triangle. It's a triangle. And how should we do this? So I think we can go ahead and say points items minimum index is the first one. Second one is going to be P2, and third one is going to be P3. Now we can remove. Well, let's add it first. Let's add it first. Got a new triangle, and then we can go ahead and remove that point. That is almost it. But we can already try running it. So let's say if is key released, maybe T for triangle. Then we are going to say expand convex hull, and what was the arguments? Expand convex hull. So it's going to be the triangles, the points. It's the first triangle, and we can go ahead and say it's the first edge as well. Actually, we can... I think there is a small problem. Let's not... Let's not remove though that point. I just thought of that. So let's... because now I want to try this. We're gonna have some kind of edge index, and we'll start out being 0, and then we will increase it, and here let's just do a check that if edge index is less than 3, then we will do this stuff, otherwise we don't do it. And what did I call them? They are called tries. But here it's called hole. Okay. Zoom in. And now if I press T, you can see we added a triangle. Why is it so freaking fast? Maybe I just decrease the decrease the FPS. So we press T, it adds a triangle down there, and you can see now if we remove the point, then if I press T again, there would be no point for the next triangle to attach to. So that's kind of why I had to remove that. But if I press T again, we get another triangle. It's a bit hard to see, but you can see there was another surface node being drawn, and finally I can add the last triangle. So now we have this closed structure here, kind of like a skewed pyramid-ish shape. Alright, so that kind of works, but let's try what happens if we create a lot of points. So let's add 10 random points. And I want to make sure that the initial triangle is still part of the convex hull. So what we're going to do is say like get a random value, maybe between 1000, -1000 and 1000. So like this, we do that a couple of times, but here it should be actually just a positive number. So with those points we can append them here, and if we run that we should see a bunch of points here, a bunch of points. Now you can see now it's actually a different triangle that should be added, and we can, well, that's clearly wrong. That is clearly wrong. So I think I know what the problem is. This should actually be minus, because of the way cosine works. So let's go ahead and try if that. Yeah, that looks more correct. And we add another one, and we add the final one. So, of course, those triangles are quite big because of the way I generated the points, but that's not really a problem. So what we need to do now is we have fully completed the first triangle, right? There's no free edges. So we need to go to the next triangle. But when we try to get a new point for the next triangle, we should kind of make sure that the point we're getting is not on an already existing triangle, right? Yeah. So I think we have to do something like, here's the candidate point. So what if that, but it's allowed to be, maybe we don't need to do anything, maybe I'm overthinking it. So let's just try something. Let's just try that if the edge index is equal to 3, then we actually need to reset it, and we need to have like some kind of triangle index that we then increase. And we have the triangle index, and then kind of if the triangle index is greater than the number of triangles, we probably should not do anything, just have a bounce check like that. And then we need to define the triangle index somewhere, which is going to be here, triangle. Okay, let's go ahead and try that out. So here we are on the outside of this cloud of points, and nothing happened because this has to be less than. All right, so try again. So we add new triangle, we add a new triangle, we add a new triangle. Now we should go to yet a new triangle and add something there. Right, so I think maybe what's happened is, yeah, we're trying to add a triangle that is already existing. So we do need to do some check here. We need to check that this new point, this new candidate point, tries count. Oh, it's not called tries in here, it's called whole. So let's have some kind of boolean that is existing triangle. Okay, so we're trying to consider whether we should make a triangle between points 1, 2, and this new point. But if that is already an existing triangle, then of course we shouldn't try to add it. So let's get the triangles that we have. Let's get the points. And maybe we'll even put this out here. And we'll say this, and we'll say if already exists, then we can just break. And here we'll say if it already exists, then we should probably skip this point because we don't want to add the same triangle twice. So now we need to implement this function, which is going to return a boolean, but that means we need to get std bool. Okay, so we take a dynamic array of triangles, we take a few points like that, and then we need to loop through the points, and we need to check whether this triangle that we now add, so this triangle, is that equal to these points, but we don't really know which order these points come in. So we have to say something like P1, P1 against A. Let's do that. And here we probably need some kind of small number. So let's say P1 equals A. Okay, that's what this means. P1 equals A. And that is true if the distance, squared maybe, between P1 and A is less than epsilon. But then we need to check all of those somehow. Maybe let's do it like this. Maybe that will make more sense to me. So here is a scenario where P1 equals A, P2 equals B, and P3 equals C. So if that's the case, obviously it's this triangle already exists and we should return true. But there's also other possibilities. For example, we could have B, C, and A. And we could have C, B, C, A, and B. Yeah, so unfortunately there's like a huge amount of things. I think maybe there's just 6. So A, C, B, and 1, 2, 3. Cannot keep track, so I'm gonna add 1, 2, 3, 4, 5, and this should be the final one. How do I know there's only 6? I know there's only 6 because there are 6 ways of arranging 3 objects. So A, B, C, B, C, A, C, B, that's 1. And let's do B, A, C, then B, C, A, and then C, A, B, and then C, B, A. So now we need to check that this stuff out here is correct. So this should be A, C, B. This should be B, A, C, B, C, A, C, A, B, and this one should be C, B, A. All right, and then let's also add a check here. So let's call it tries. Let's call it is try. So is try is equal to is try or P1 equals A and P2 equals B and P3 equals C. And if is try, then we can return true already. Yeah. So now we need to go ahead and change this one. This one, B, A, C, and B, C, A, C, A, and B, and C, B, and A. All right, and I just realized we probably don't need this. So let's remove that. Okay, and if none of those happen, we return 0. So let's try that algorithm, and that of course didn't even compile. Because that one already exists. And there's a bunch of them that already exist, so I'm just going to go through the compilation errors like this. All right, go to the back and let's try to add some triangles. So this we could already do. Let's see if we can add another one. And that did not work initially. It seemed like it didn't work. So what actually happened? I press T and nothing happens. So let's add some reporting. Adding a new triangle, and it's going to be a new line, and here it's going to be 0.1. It's going to be some floating point numbers, maybe just 4 digits, and it's going to be P1, P1Y, P1Z. Second one is that. Third one is this. Let's go ahead and try that. So we can go ahead and make the first 3, and that has printed a bunch of stuff. Now let's try to add one more. So that is indeed the triangle. Yeah, that is unfortunate. That is the same one that we just added, which is weird because that should be checked. Let me go ahead and try to align on equals. It's a little bit excessive, don't know why I did it like that. Okay, so let's double check it. We have ABC 1, 2, 3, ACB 1, 2, 3, BAC 1, 2, 3, and we also have to check that these things are correct. So that's probably kind of an issue with this way I've written it. There's like too many places it can go wrong, but to be fair, it's not that difficult to check. But maybe we can see, we can get a hint as to what goes wrong. So this one is equal to that one. This one is equal to that one. And that one is equal to that one. So this should be something like... Yeah, well, okay, so we also need to know what is P1, 2, and 3 for this to work. Let's close that. Let's do this, so let's do, wait, so we already have P. Wait, so I'm confused. These are the points of the existing triangle. Let's say existing triangle. And new point. And what is the new point? New point is going to be points, items, minimum index, something like that. All right. So here we have 3 points. Okay, whatever. Right, so existing triangle, of course, that's fine that is the same. Should be the same. Now when I press T, nothing happens. Okay, it's because we're down here incrementing incrementing triangle index. One, two, three, and then now we actually incremented. Yeah. So that's actually normal. You press 3 times and then nothing happens. So 1, 2. And a crazy one. And where does it start from? What the hell is happening? Okay, let's just try to run it to completion, see what happens. Something is wrong because it should not make this many triangles. And here we can go ahead and say done. No more free edges. Okay, so something is still going wrong. And let's see if we can get some kind of hint what that is. There was a very weird case. Yeah, so like this is wrong. Pretty sure this is wrong. But oh, is it? No, it's not wrong because it was over there. It was over there. Okay, we had another one. Now that is surely wrong. I'm going to do something because it's hard to see what's happening. So if, so let's say color is blue, but if we are at the very last one that's added, then the color is something else. And what should it be? Maybe we just try to make it white. So I have here color. And this should be uppercase. Right, so this is the latest. We add this one. Looks good. We add that one. That is so strange. One more thing we can do is if I is equal to try index, then maybe the color is red. So this is kind of the one we want to add things to right now. So we add that one, we add that one, we add that one. Now we want to add to this. Okay, so now we can also see that what's happening, why it's not adding a triangle, because it changed which one is red. We add this, and then we add that one. Right, so the issue is that this edge should not get a new triangle. This one already is part of two triangles, so we don't want to give it a new triangle. So actually we kind of have to loop through the triangles up here. And we have to say edge exists. Yeah, edge exists. Let's go with that. So here we can say has edge, all items I, and this is the edge. And basically, if the edge exists, we can just return, like we don't want to do anything here. So because the edge index and stuff is handled outside of this function cannot do anything more. However, of course, the edge will always exist for this triangle. So in that case, we just skip ourselves. So now we have to implement has edge. Which takes a triangle and a couple of points. So now we kind of, we need an epsilon again. And let's say P1 equals A. We kind of need this stuff again almost. No, sorry, distance squared between P1 and try A. And there is an edge between A and B. So we need to check that. There's an edge between B and C. So we need to check that. And there's an edge between C and A. So we need to check that. And then we need to check the things where they are reversed. So essentially, let's say its first edge is something like this one is less than epsilon, and this one is less than epsilon. Can I do something like this? Right. or the same thing, but those flipped. Sorry, A. And then we have the second and the third edge. So if P1 is B and that one is C, or this one is B and that one is C, and here if it's the third one, then that one is C and that one is A, or this one is A and this one is C. And if none of those are true, we can return false. So if P1 is equal to A and P2 is equal to B, or P1 is equal to B and P2 is equal to A, then those two edges make up the first, those 2 points make up the first edge of the triangle. Then we check B and C, and then we check C and A. So let's go ahead and try that. Okay, we have the active triangle, we add triangles, we switch to a new active triangle, we add a triangle, that looks correct. Now we have probably go to the edge that's already connected, so that nothing should happen there. Nothing happens. We go to the next edge and then we add that one. So let's try to run it. I'm just gonna press T until it kind of stops updating. And now here it should say done. I thought it was going to say done. Okay, now it does. There was apparently something missing that I didn't really realize. So now it says done, no more free edges. And we have constructed a convex hull. Of this set of points. Very nice. Let's remove these normals from being drawn. And we can have this incremental, that's kind of nice to have that, but let's have one that is just running everything. So here we can say while this is not, well, there's still some free triangles, we just run it. And I think we don't want it to print stuff. Probably up here, we don't really need this debugging anymore. I will leave it in, just in case. Let's see if we have any more weird debugging. This one I really don't want. This is okay. And I think that's it. So we can go here and we can press R and it just almost instantly. I mean, of course, it's not a very efficient algorithm, but it works and we can already start to play with this. But that's something we'll do in the next video, where we'll try to apply this to this bunny that we made. How do we do that? We go into run, and here we're gonna say main, and now we'll get this guy. So we'll try to create a convex hull for that, send it to the GPU and render it. But that's for the next video. So until then, bye bye.